So this first video is meant to give you some background information about those 5 questions. When you come into class the next day, you're going to get a problem related to one or a combination of those 5 questions. So you do the homework to prepare for the quiz the next day. Don't have to watch the video, but it can be helpful. We've been talking about atomic structure in class, and we know that the nucleus of an atom, that's the interior region here, contains protons and neutrons. It's actually much smaller than the overall size of an atom. Some people will say that atoms, thus human beings or everything, is just empty space because all the mass of an atom is in the nucleus. Actually, if you had a carbon atom the size of a BB, like from a BB gun, that carbon atom would weigh about as much as an elephant. Mathematically, you can do that calculation. Thus, the nucleus of atoms are very dense. Okay, but it helps, for the sake of this drawing, not to draw it that way. Around the outside, we have the electrons and these energy levels. Okay. Really, the solar system model is not a good model, but it helps us in understanding atomic structure. It's better to think of the electrons as bees buzzing around a hive rather than planets floating around some sort of epicenter. But for the sake of this, we're going to do it that way. And I'm going to keep electrons the same color as the protons, since they are the only 2 species or particles that have a charge. Okay. So when we look at this here, another term for the number of protons in here is the atomic number. So in this case, the atomic number equals 2. And this gives us the identity of the atom. So we know that this is helium because it has 2 protons. We can add as many electrons as we want and as many neutrons as we want, or take away as many electrons as we want, or take away as many neutrons as we want, but it will still be helium if it has 2 protons. The atomic mass is the protons plus the neutrons. Okay? And in this case, that's 4. Now, if you notice on the periodic table, that number is rarely a whole number, and we'll get to that in a sec. So let's look at carbon. For example, this right here is the atomic number of carbon. That means that there are 6 protons in the nucleus. This number here is the atomic mass. Why don't we go ahead and do that in red? Okay, so we know we have 6 protons, but the question is here, how many neutrons do we have? Because this is not a whole number. And the truth is, sometimes we have 6, and sometimes we have 7. And that gets into this definition of something we call an isotope. Carbon can come in 2 forms. It can come in carbon-12, and it can come in carbon-13. Okay? Carbon-12 has 6 protons and 6 neutrons, since it has a mass of 12. And carbon-13 has 6 protons and 7 neutrons, since it has a mass of 13. This is the most abundant isotope. For example, if you had all B's and 1 A, your grade would be closer to a 3.0 than a 4.0. Well, in nature, there's more carbon-12 than carbon-13. Thus, the average, but not just the average, the weighted average is closer to 12. If this number was closer to 13, like 12.99, we could hypothesize that there's much more carbon-13 in nature. Okay? So that really gets at why that number on the periodic table is not whole. Let's focus now on the charged species, the protons and the electrons. So if we look at this, xenon, it's a noble gas, we see that xenon here has protons equal to its atomic number. That's 54. And let's say, because it's a noble gas, this is always the case, the electrons were 54. Okay? Well, what would the net charge be? In this case, the net charge is equal to 0. And anything with a net charge that's equal to 0, we refer to that as the neutral atom. Let's look at another circumstance. Okay. Here, chlorine. Chlorine has atomic number equal to 17, so its protons equal 17. Now, chlorine, and we'll learn why in class, tends to form what we call an ion with electrons equal to 18. So what's the net charge? 1 minus. And it's sort of silly in chemistry. We say the number before the charge. So instead of minus 1, we say 1 minus. It's got 17 plus things and 18 minus things. The minus things win by 1, so it's 1 minus. And we call this an ion. Okay? And not just any kind of ion, we call it an anion. Okay, and I always just remember that little N for negative. That's an anion. Let's look at calcium. Calcium has atomic number equal to 20. That means it's got 20 protons. And calcium can be neutral, but calcium tends to form something that has 18 electrons. And again, we'll learn why next class. So what's the net charge? Well, the positive things win by 2. So is it plus 2 or 2 plus? 2 plus. So this is not an atom. This is an ion. And instead of saying an anion, we say a cation. And the way I remember this is T looks like a positive